difference between concentration and strength when referring to acids and bases, okay? Now, concentration we learned about when we were talking about solutions. Concentration is, generally speaking, the amount of acid or base per amount of water. So when we're talking about concentration of acids and bases, we are specifically talking about how much acid or base is present, okay? Now, usually in chemistry, this is our most common way to express concentration is molarity. And if we remember, it specifically means moles per liter. Moles divided by liter. And moles is going to be the number of moles of the acid or base divided by the liters of solution, okay? So how much acid do we have present, okay? Now, for acids and bases, acids especially, 12 molar is typically pretty concentrated. That's what we talk about when we're saying that something's very concentrated. What does that mean? It means it has a lot of acid or base dissolved in water, okay? Whereas if we have like 0.1 molar, that's going to be dilute, okay? So we're talking about, this would be 0.1 moles per liter of solution, so not a whole lot of acid. Which one do you think would be scarier to hang around? Definitely the concentrated acid, okay? So there's concentration. Now let's talk about strength. Strength is different than concentration. Strength is how well an acid or base ionizes. Ooh, we have to remember back to electrolytes to remember what that means. Ionizes is to split apart into ions. You remember electrolytes ionize, and if you remember that acids and bases are both electrolytes. So now, how do you know which acids and bases are strong and which ones are weak? You just memorize them. There's not a whole lot of patterns. It seems kind of random. You just have to put the time in to memorize them. And yes, you do need to. So I would start working on that, okay? But strong acid is one that ionizes almost completely. So let's write this ionization reaction. HCl plus water yields H3O plus and Cl minus. Okay. So there we go. All of this becomes H3O plus and Cl minus. It ionizes almost 100%. Okay? That is what a strong acid does. Okay. Weak acid, hydrofluoric acid, is a weak acid. How do we know that? We just memorized it. Now, it does a little bit turn into H3O plus and F minus. Okay, it does do that. However, it does not do that fully. In solution, there's still some HF, some H3O plus, and some F minus. And that's why I made this a reversible reaction. Any weak acid is actually reversible. This does react with this to form these ions. It does ionize, but then these do actually go in reverse to form HF again. If you had a solution of this in a beaker, okay, it would actually look like this. There would be some H plus. Now, for shorten it, I'm just going to write H plus to remember that those are basically the same thing. Okay, and F minus, F minus. There would be some of that. But in reality, there still would also be some HF hanging around. So not all of it ionizes. That's what it means by being weak, okay? Weak does not mean that it's not as dangerous. Necessarily, we can have weak acids that are very concentrated. And actually, hydrofluoric acid is not an acid you want to hang around even though it's weak, okay? But do you see how pH refers to the concentration of this, the negative log of the concentration of this. So if it ionizes less, generally speaking, HF would have a higher pH than HCl would, okay? But concentration is also going to affect pH as well. So that's just something to be thinking about. Okay, so let's talk about if we had 12 molar HF. Would this acid, hydrofluoric acid, be concentrated? Well, yeah. Why? Because it has a very high molarity. But HF is a weak acid. So you can, in fact, have a concentrated weak acid. You can also have a dilute strong acid, 0.1 molar HCl. We have a dilute acid that's also strong. That means 100% of this HCl almost is going to turn into H plus and Cl minus. But there's very little of it in solution, okay? I would guess the pH probably would be lower here. So pH, remember, does depend on concentration and strength, okay? Good. So, there you have it. Concentration versus strength. I would start working on, right now, memorizing your strong and weak acids and bases. Remember that bases always also are the same thing here. If it's a strong base, it's going to ionize completely. If it's a weak base, it's only going to ionize partially. So those are the same things whether we're talking about acids or bases. So there you have it, strength versus concentration.